Hello, we are Team BFS, and for our project we implemented Throbot, a free-throwing robot. Throbot will pick up a ball, approach a hoop, and make the shot once it has reached an appropriate distance. For this section of our code, Throbot will find the signmost pixel in its environment and then face itself towards it. As you can see, Throbot is aiming towards the hoop, more specifically the sign note on the hoop. Originally, we were going to go with a red target. However, there was a lot of interference in the room and other sensor input for Throbot to face, so we decided that cyan was the best color to go with.
Target tracking is split into two main components: aiming at the target using the Xbox Kinect's camera, and approaching the target using the Kinect's laser rangefinder. For both of these components, we utilize PID controllers to ensure that the movement of the robot was smooth and accurate. The aiming code, which points the robot towards the cyan object, was based off of our Vision lab. The code to then approach the target was taken from our first PA.
The other main component of our program is the actual arm motion. The arm is controlled by 5 servos, one which controls the gripper hand and allows it to grip and release the ball, one for each of the 3 main joints, and one for the base that allows it to rotate. Each joint allows the arm to move on 3 degrees of motion and can be controlled individually or all at once by publishing messages to each's corresponding ROS topic. Clearly, moving the arm was something that was important for us as we wanted it to throw the ball. Here's the part where everything has to come together, where we run the entire project. When we launch our project, we launch 3 nodes, one for the aiming, one for the approach, and one for the arm control. The arm moves to an initial position, moves to pick up the ball, picks up the ball, and then moves back to its throwing position. That's when the aim and approach nodes start moving, find the target, and move towards the target until they are within throwing range. Once the robot is within throwing range, it then throws, and it scores.
Now we're going to look at more detail at the actions that the robot performs. Here's a close-up view of the motions that the arm performs to pick up the ball. And now we show an alternate view of the robot actually making the shot. And now here is a robot's eye view of the target finding. We blur the image as this helps reduce noise in the environment and the camera. As you can see, the cyan target is marked with a red dot. And here's what happens when good code meets bad execution. As we all know, robots have an ego. The robot starts off just fine, but instead of aiming toward the cyan target on the hoop, it finds an alternate target in the back corner of the room.